Okay, here we're finding the geometric mean of each pair of numbers. Essentially what this means is you're going to multiply the numbers together and then square root it. Okay, what does that look like for us? For number 13, we can say if we were to multiply these numbers together, we would, essentially what we're saying is we could say like x squared equals 3 times 48. So then x is the square root of 3 times 48. That's kind of what we're doing. And actually, I'm gonna grab that and put that over here. Okay, so if that's true, then what we really want to do is we want to figure out how do we square root 3 times 48. Well, if we're going to do that, I'm going to continue writing this. I'm going to say x is really then equal to the square root of, and I want the prime factorization of this. So I want 3 times, and now I want to break down 48 into its prime factors. I've got 6 times 8, not prime, so 3 times 2, those are prime. 4 times 2, that's prime. 4 times 4, 4 is 2 times 2, those are prime. Okay, so now we've got another 3 there. This was the original 3 from there. And now the rest of it is lining up 48. Okay, so the 48 breaks down into 3 times 2 times 2 times 2 times 2. Okay, this is the original 3 that we got, one of the numbers that they gave us. And this is the 48. 3 times 2 is 6. And 2 times 2 is 4 times 2 is 8. So this is 6 times 8. 6 times 8 is the 48. That's the other number they gave us. Got it? That's where we got those numbers from. It's just listing out the prime factors of the two numbers and putting them all under there. I'm going to get rid of this. And then what we're saying is, okay, if we want to square root something, if it's inside twice, we can bring it out once. So we've got x being equal to, and what's inside? Well, we've got 2 3s. We can bring that out as a single 3 times, what else can we bring out? We can bring out a pair of 2s as a single 2. And what else can we bring out? We can bring out another pair of 2s as that final 2. And then x is equal to 3 times 2 is 6 times 2 is 12. Now the square root of that number is 12. So what would have been that number if we multiplied it together? Can you guess? Yep, that's right. 12 squared, 144. So let's actually take that 3 times 48 that they gave us and see that. Yep, 24, carry the 2. 3 times 4 is 12, plus 2 is 14. So what you can say is, oh, wouldn't I have been better off actually multiplying these numbers together to get 144? And then, because I knew that that was just square rooted to 12. Yeah, probably. Probably that would have helped you. You can multiply bigger and then examine the number. You may have to break it down using prime factorizations eventually on your own. And of course, as you get better at this and you understand, like I know, because I've been doing it for a long time, I know that that's prime. I know how this breaks down. I can do that in my head to give the prime factors. And then I know that, aha, this is going to have a single 3 in there, and it's going to be matched by that 3, so it's going to end up working out perfectly. Okay, so now number 15, let's do that one. So we say we want the geometric mean. So essentially we want the square root of these two numbers multiplied together. What are those two numbers multiplied together? There's 7 times 9 is 63. So what I want to do is I want to take 63 and I want to do a prime factorization. Well, already because I multiplied 7 and 9 to get it, I know that they break up into 7 and 9. That's prime. This breaks down into 3 and 3. So I could write this as the square root of 3 times 3 times 7. And what can I get out of there? Well, we could take the 3 out. putting that out front as 3. And there's 7 has no match, and it's also not a perfect square. So I have to leave that inside. And so I can say x, the answer that would be, is 3 root 7. They didn't really ask us, they didn't mention the value x, or the variable x. I was just showing you that we know that the geometric mean is going to be the two numbers they gave us multiplied together and then square rooted. So that's essentially like saying x squared is equal to what they get when you multiply them. Okay, we're going to do this final one. And let me get this junk out of here. It's not junk, it's just we don't need it anymore. Clog us up visually. Okay. One last number, 4 and 49. So we could, if I wanted to go back to saying x squared equals 4 times 49, you could do that. Really what you're saying is we're looking for the answer square root of whatever you get when you do 4 times 49. Now, this is a great one. The reason that it's a great one is because if you look at it, you can see that, oh yeah, both of those numbers are already perfect squares. 4 is a perfect square of 2, and 49 is a perfect square of 7. So instead of seeing a number twice, like we did up top, you see it twice, you bring it out once. Another way of saying is, if it's a perfect square, we can bring it out as its square root. So this one then would come out to be, the 4 comes out as a 2, and the 49 comes out as a 7, both of their square roots, which when multiplied together gives you 14. Okay, that's your answer. But let's just say, instead of saying 4, the square root of 4 times 49, which is really another way of looking at it, is saying the square root of 4 times the square root of 49, or 2 times 7. Okay. You could have broken that down. So another way of looking at it is to say, oh, I didn't really think about them as being perfect squares, so I ended up breaking them down. Well, what'd you do when you broke them down? What'd you get? Well, you'd got 4 breaks down into 2 times 2, 49 breaks down into 7 times 7, and then you say, oh, well, if I see a number in there twice, I can bring it out once. If I see a number in there twice, I can bring it out once. And you still get 2 times 7, or 14. Okay. The geometric mean, just to recap, up here at the top, the geometric mean, what they're asking for, what they are saying to do is to multiply the numbers together and then square root them. And you need to know how to simplify square roots. Kids are like, oh my God, they freak out a little bit. What is that? Do we really have to do that? And my response is, yeah, you do. You have to become comfortable with the skills that we taught you in the past, or that you should have learned in the past that you need to know. If for any reason a skill wasn't taught to you, but you need to know it, then that means that now at this point, when they're expecting you to use it, I guess you have to learn it now if you didn't learn it before. That's just a reality of this kind of stuff. You have to master skills that you don't have. Sometimes it's shown to you and you didn't master it, then that means you got to continue to practice it and get it later. Or sometimes maybe, I don't know, I wasn't there in the past, maybe it wasn't ever shown to you, and in which case, well, you still, even if that was a failure on an old teacher's part or whatever to show you, you still are going to have to know. You can't just, for the rest of your life, point backwards and say, my teacher never showed me that. You have to master things at some point on your own. So just accept it and say, okay, I got to study this. I got to do this. We do need you to do it. So get it in your belt. And so just to one last time, let's just box out our final answers. The geometric mean, this one is 12. This one is 3 root 7. And this one is 4.